Today also we are working on the confidence interval. We are going to solve few examples on confidence interval. We are going to start with the first example here. Example, determine whether to use Z alpha over 2, that is Z critical, or T alpha over 2, that is T critical. What we have to do is we have to find the critical value by drawing the curve and properly labeling it. So here is the curve. We are going to label that. What we have to do is we have to find the critical value, whether we need Z alpha over 2 or T alpha over 2. We need to determine that. And we have to find the proper critical value for the information given here. N equal to 8. You can see S equal to 3. That is the sample standard deviation equal to 3 for a 95% confidence interval. So if you look at it carefully, you can see that they have given the sample standard deviation. And when sample standard deviation is given, we use T alpha over 2 or T distribution. So we are going to write that first. Population standard deviation is unknown, so we are using T alpha over 2. We need to find the critical value. So this distribution here is now a T distribution. This is the T distribution. And whenever we are working on T distribution, we need the degree of freedom. Here, the value of N is 7. So the degree of freedom is N minus 1. I mean, value of N is 8. So the degree of freedom is N minus 1, which is 7. So this distribution is T distribution with 7 degrees of freedom. So along the x-axis here, we have the T values. We have T, random variable T along the x-axis, and we have a T distribution. We want the critical value for 95% confidence interval. So when we say 95% confidence interval, the middle 95% area is here. So we are going to label that area. So the area in the middle is 95%, 0.95. Because we are looking for 95% confidence interval. So for 95% confidence interval, we want the critical value. So this is T sub C or T alpha over 2, which is same thing. And this is negative T alpha over 2. Now you can mark the area on the tail. The area on the left tail plus the area on the right tail is 100 minus the area in the middle. So 100 minus 95%. So this total area is 5%. And that 5% is equally divided into two parts. 5 divided by 2 is 2.5. So this is 2.5%. This is 2.5%. 2.5% or 0.025. 0.025. 2.5%, which is 0.025. Now, after we have all this area, we can easily find T alpha over 2. We are looking for the critical value, which is T alpha over 2. Now, the critical value T alpha over 2 is equal to, whenever you are calculating the value along the x-axis, we use the inverse distribution. So in this case, it is inverse T. So inverse T. Then we write the area to the left of T alpha over 2 because we are calculating T alpha over 2. Area on the left of that, here we have 95% in the middle. And here we have 2.5%. 95 plus 2.5 is 97.5, or 0.95 plus 0.025, which is 0.975. So the area is 0.975, which is 97% area. Then we put a comma, and then we write the degrees of freedom, which is 7 because the sample size is 8. 8 minus 1 is 7. So here we write 7. So the degrees of freedom is 7. So this implies your critical value T alpha over 2 is equal to. So in our TI-84 calculator, you have to go to second, vars, and number 4. So in order to execute the calculation, please try that. You have to go to second, then vars, and then 4. Second vars number 4, and put the information for the area and degrees of freedom. Paste it to the main screen to get this one, and then write down the result. So the result must be 2.3646. So that is the critical value T alpha over 2 for the situation given here. Example, determine whether to use Z alpha over 2 or T alpha over 2. Find the critical value by drawing curve and properly leveling it. And the situation given here is n equal to 10. Sigma, the population standard deviation, is 3 for a 95% confidence interval. So here they have given the population standard deviation. So we use Z alpha over 2. So because the population standard deviation is given, we are using Z alpha over 2 so that the Z scores are along the x-axis, and this distribution here is a standard normal distribution, meaning of that is mean is 0 and standard deviation is 1. Now we want the critical value Z alpha over 2 for 95% confidence interval. So in the middle, we'll have 95% area, which we are going to label first. So this area in the middle is 95% or 0.95. Let's label that area. So this is our 95% area. And the value here is Z alpha over 2. Z alpha over 2. So by symmetry, that value on the left is negative Z alpha over 2. Negative Z alpha over 2. Now, out of 100% area, you have 95% area in the middle. So on the two tails, the total area on the two tails, if I add this area and this one here, the total area is 5%. So 5% is divided into two parts. So this will be 2.5% or 0.025. And this one is also 0.025. So once we have everything set up and the picture is clearly labeled, we can find the Z alpha over 2. Now, Z alpha over 2, because we are calculating the variable along the x-axis, we use the inverse distribution. In this case, we are using the inverse of the standard normal distribution. So we write inverse normal. Then we want the area to the left of Z alpha over 2. So here we have 95% area. Here we have 2.5% area. So the total area from here all the way to the left tail is 97.5% or 0.975. Mean is 0. Standard deviation is 1. Now we need to use our TI-84 calculator to compute this. So what you'll do is in your TI-84 calculator, you go to second, then vars, and number 3. And after you go there, put the proper area, mean, standard deviation. Your area is 0.975, mean is 0, standard deviation is 1. And then paste this in the main screen to get this display. And you'll get the result. You must try this in your calculator. So by typing this information in the calculator, you should get Z alpha over 2 or Z critical as 1.96. So the critical value for the situation given here at 95% confidence level is 1.96. Example, in a study of 10 middle school children, so the information given here is n equal to 10. In a study of 10 middle school children, that's your sample size, the mean number of hours weekly spent playing video game was 15 hours. This is the amount of time they spent playing video games on average. So that is the sample mean with a standard deviation of 2 hours. Sample standard deviation is 2 hours. We need to find the 99% confidence interval. Now we need the confidence interval, and it must be a 99% confidence interval for the true mean number of hours weekly spent playing video games. So let's first write the given information. Here they have given n equal to 10, sample mean equal to 15 hours, sample standard deviation equal to 2 hours, and confidence level is 99% or 0.99. Now you can clearly see here, in this case, they have given the sample standard deviation, but the population standard deviation is unknown. So since the population standard deviation is unknown, we are going to use the t-distribution. So let's write that down. Since population standard deviation sigma is unknown, since population standard deviation sigma is unknown, we use t-distribution. So we are using the t-distribution. And in this example, we are constructing a 99% confidence interval. So whenever we are constructing the confidence interval, in the middle, we have the point estimate. Because we are talking about the mean, point estimate will be sample mean. And then on the left end of the interval, you'll have the mean or the point estimate minus the margin of error. And on the other side, you'll have the point estimate plus the margin of error. So two things that we want here are the point estimate and margin of error. So let's first write what we have. Point estimate, point estimate is our mean, sample mean. It's already given, it is 15. So we have the point estimate of 15. It's given to us. Next, we need the margin of error. So let's see how we can find that. Margin of error, we write ME is equal to, if you remember the formula, we are using the t distribution here. So it should be t critical multiplied to sample standard deviation divided by the square root of n. So we have this sample standard deviation here. We have the n equal to 10. We don't have t critical. So first we are going to find t critical using the t distribution. So this is our t distribution. T distribution with your n is 10. So 10 minus 1 is equal to 9 degrees of freedom. 9 degrees of freedom. So that along the x-axis, you have the random variable t. We are looking for 99% confidence interval. You can see 99% confidence interval. So in the middle, you have 99% area. So 99% area is in the middle. We are going to label that first, 0.99. So this area in the middle is the 99% area. That is 99% area. So that the value here is t critical. And this is negative t critical. You can also write t alpha over 2, which is same thing. And here you can also write negative t alpha over 2. Now, you have 99% area in the middle. So area is on the tail. If we add this area on the right tail and area on the left tail, it is equal to 1%. But that 1% is divided into two parts. So 0.5% on each side, which is 0.005. And this is 0.005. That is 0.5%. Now to find the t critical, you know that t critical is inverse t. Area to the left of this t, 99% plus 0.5% is 99.5 or 0.995. And your degrees of freedom is 10 minus 1, which is 9. So 9. Now, if we type this information in our calculator by going second vars and then number 4, you should get 3.2498. Make sure you try that in your TI-84 calculator. In order to get inverse T, it is second vars number 4. You put the area and the degrees of freedom, you should get 3.2498. So we need this T critical in order to calculate the margin of error here. So let's plug in back there. So in place of T critical, we are writing 3.2498 multiplied to the sample standard deviation, which is 2 divided by the square root of n is 10. Now we are going to simplify this using calculator. And by simplifying this, you must get 2.0554. 2.0554. So that is the margin of error. In order to construct the confidence interval, we need the point estimate. We got that. We need the margin of error. We got that one too. So what we need is we need the left end of the interval, which is mean minus margin of error. And also we need the right end of the interval, which is mean plus margin of error. So we are going to find those two end values now. Now, mean minus the margin of error is equal to 15 minus 2.0554. If you subtract this, you should get 12.9446. And the next is mean plus margin of error. Mean is 15 plus margin of error is 2.0554. So 15 plus 2.0554 is 17.0554. So the meaning of that is we are 99% confidence because we are constructing a 99% confidence interval. We are 99% confident that the true mean number of hours weekly spent playing video game is between these two values. So that will be our conclusion. So we are going to write that conclusion now. We are 99% confident that the true mean lies between 12.9446 hours to 17.0554 hours. Example, a group of 90 community college students, that is your sample size, were asked if they plan to transfer to a 4-year university upon the completion of their associates in arts. So when you ask 90 students, the response was this: 81 of them stated that they plan to transfer. So 81 will be transferring to a 4-year university upon completion of their associates in arts. We have to find the 99% confidence interval, 99% confidence interval for the population proportion. Here we are talking about population proportion, P. So the confidence interval will be based on P and P hat. So let's write down what is given first. Here they have given n equal to 90, or they have asked 90 people or 90 students, and 81 of them said they are transferring to 4-year university. So x equal to 81. We need to construct a confidence interval with confidence level 99% or 0.99. Now we can easily calculate the proportion of a student P hat transferring to 4-year university. It is 81 out of 90. So 81 out of 90, which is equal to 0.9. If we divide 81 by 90, it is 0.9. So this means that if we want to find Q hat is 1 minus P hat, so 1 minus 0.9, which is equal to 0.1. So we have P hat, we have Q hat, we also have N. In order to find the confidence interval, what we need is we need the point estimate in the middle, which is P hat. So point estimate here, Let's write that down. Point estimate is p hat, and we already have that here. P hat is 0.9. P hat is 0.9. It's already there. Now, once we have the p hat, we need to add and subtract the margin of error. To get the right end of the interval, we add the margin of error. To get the left end of the interval, we subtract the margin of error. P hat minus margin of error. Because by doing this, we know that our true population proportion lies in that interval. Okay, let's find the margin of error. Margin of error, which is ME. If you remember the formula for margin of error, it is Z sub C P hat Q hat divided by N. Inside the square root, we have P hat Q hat divided by N. So we have P hat, we have Q hat, which is here. P hat is 0.9, Q hat is 0.1, N is 90, but we don't have Z sub C. So first, we need to find Z critical at 99% confidence level. So in the normal distribution along the x-axis, you have the Z score. In the middle, you have the 99% area, which we are going to label first. So the area in the middle is 99% or 0.99. This is our 99% area. So that this is Z critical and this one is negative Z critical. We need to find that Z critical. Now the area on the tail is the 1% area divided into two parts, because in the middle you have 99%. So remaining 1% is divided into two parts. So you have 0.5% each, which is 0.005 and 0.005. Now once we have this information, we can easily calculate Z sub C, which is equal to inverse normal. Area to the left is 99% plus 0.5%, 99.5%, or 0.995. Mean is 0, standard deviation is 1. Now, if we type this information in our TI-84 calculator by going to second vars and number 3, the result must be 2.5758. 5758. That is your Z critical. We calculated this Z critical because we need that here. So let's plug in the value of Z critical. So we got this as 2.5758 multiplied to the square root of P hat is 0.9, Q hat is 0.1, divided by N is 90. Now we need to simplify this using calculator. So 2.5758 times, make sure you use multiplication sign in calculator, then is square root. Inside the square root, we have to type 0.9 times 0.1 divided by 90. So by simplifying this, you must get 0.0815. So that is the margin of error. So we got the point estimate, which should go in the middle, and also we get the margin of error. So once we have the point estimate and margin of error, we can add and subtract to get the end point of the confidence interval. So let's do that. Point estimate minus the margin of error. P hat minus margin of error. That is 0.9 minus 0.0815. If you subtract that, you should get 0.8185. And then P hat plus margin of error, that should be 0.9 plus 0.0815. So if we add this, the result is 0.9815. That means with 99% confidence, we can say that the true proportion of a student transferring to four-year university lies between these two values. Meaning of that is 81.85 to 98.15% student transfer to a four-year university. So let's write that conclusion. With 99% confidence, we can say that the true proportion of a student transferring to four-year university lies between 81.85, which is same as 81.8185, which is same as 81.5%, and 98.15% or 0.9815. So that is the conclusion, and this is the confidence interval that we have created for this problem. Example, from a study conducted of 250 online shoppers, an online retailer determined that the average amount of time shopper who shop online at night is 20 minutes. The population standard deviation is assumed to be 30 minutes. We have to estimate the population mean time spent shopping online at 90% confidence level. So let's see that they have given few important information here. The first one is they conducted the survey on 250 online shoppers, that is your N value. And they found that the average time they spend shopping at night is 20 minutes. That is your mean for the sample. And also they have given the population standard deviation is 3 minutes. We have to construct the 90% confidence level. So if we collect this data here, you'll see N equal to 250. N is 250. Sample mean is 20 minutes. Standard deviation is 3 minutes. And the confidence level is 90%, 0.9. Or you can write 0.90, it's the same thing. Now in this case, they have given the population standard deviation. So we use the standard normal distribution. You can write that. Since sigma is given, we use standard normal distribution. We use standard normal distribution. We'll be using the standard normal distribution. And we are looking for the confidence interval. Whenever we are looking for the confidence interval, in the middle we have the point estimate. In this case, because we are estimating the true mean, so you'll have the sample mean or the point estimate in the middle. And then this side you'll have the mean plus margin of error, that is the right end of the interval, and the left end of the interval will be mean minus the margin of error. So with 90% confidence, we can say that the true mean lies in this interval. So let's begin with the point estimate first. So here the point estimate is X bar, or the mean, sample mean. It's already given, it's 20. We have that. Next, we need the margin of error. Margin of error. And the formula to find margin of error is Z sub C multiplied to the population standard deviation divided by square root of N. We have the population standard deviation sigma here. We have the N, which is 250. We don't have Z critical. So first, we are going to find Z critical using the standard normal distribution. So in a standard normal distribution, you have the Z score along the x-axis. We are looking for 90% confidence level. So the area in the middle is 90%. This is the middle 90% area. This is your middle 90% area. So that this value is the Z critical, Z sub C, and this is negative Z sub C. Since we have Z sub C and negative Z sub C here, and the area in the middle is 90%, the remaining area on the tail is 10% divided into two parts, so 5% each. So this area on the left tell is 5% or 0.05. And area on the right tell is also 5%, which is 0.05. Now, in order to find z sub c, we use the inverse normal distribution. Inverse normal in our TI-84 calculator, we go to second vars and number 3. Then we write the area to the left of z sub c. Area to the left of z sub c is 90% in the middle and 5% here, which is 95% or 0.95. Mean is 0, standard deviation is 1. So if we perform this calculation in our TI-84 calculator, you should get 1.6449. That is Z critical at 90% confidence level. Now we are going to substitute this value into this equation to find the margin of error. So Z sub C is 1.6449 multiplied to population standard deviation is 3 divided by the square root of n. N is 250. That is our sample size. Now let's simplify this using calculator. After simplifying, the result is 0.3121. So that is the margin of error. So we got the point estimate, which goes here in the middle, and we have the margin of error. That means we can add and subtract the margin of error to get the boundary for the interval. So let's do that. So this implies the point estimate minus margin of error is equal to 20 is the mean or the point estimate minus the margin of error is 0.3121. So 20 minus 0.3121 is 19.6879. Similarly, mean plus margin of error. If we add, this is equal to 20 plus 0.3121, which is equal to 20.3121. So the 90% confidence interval is from 19.6879 up to 20.3121. So that is the interval. Sometimes we can also write interval like this, 19.6879 up to 20.3121. You can also write the interval like that. So meaning of that is true mean lies between these two values, and we can say that with 90% confidence. So let's write that conclusion. We are 90% confident that the true mean lies between 19.6879 and 20.3121. Example, a professor for a large class is worried that his student spend too little time studying. Okay, that is the concern. That is the professor's concern. At 98% confidence level, that's your C value. At 98% confidence level, the professor needs to determine the sample size needed for a study that he will conduct on the average number of hours study weekly for his entire class. So you want to study whether they are studying few hours, very little every week. So in order to do that, you need to have a proper sample size. So he wants to determine the sample size. He is assuming that the population standard deviation, that is the number of hours they studied, is 2.9. So population standard deviation is 2.9. Population standard deviation number of hours is 2.9. And the margin of error that he is looking for is 2 hours. So it can be the point estimate plus 2 hours or point estimate minus 2 hours. That is the margin of error. So with that information, we need to find the sample size. So let's write down what is given first. then it will be a little more clear. Here you can see that the confidence level is 98%, so C is 0.98. Population standard deviation is 2.9 hours. And the margin of error is given, it is 2 hours. We need to find the sample size. So if you remember the formula to calculate the sample size, n is equal to z sub c multiplied to sigma over margin of error squared. This is the formula to find the sample size. You have the sigma, you have the margin of error, but you don't have z sub c. So first thing we need is z critical. So we are going to use this distribution, z distribution, and find the critical value. Along the x-axis, you have the z value. We are at 98% confidence level. So middle 98% area is here. So let us label that 0.98. You always have to draw the level diagram. So the area, then calculate the critical value. So this is z sub c, this is negative z sub c. You have 98% area in the middle, so remaining 2% is divided on the two tail. So each tail has 1% area. So this area is 1% or 0.01, and this area is also 1% or 0.01. Okay, once you have that, Z critical is inverse normal. Area to the left of Z sub C is 98% plus 1%, which is 99% or 0.99. For the standard normal distribution, mean is 0, standard deviation is 1. Now, if we use TI-84 calculator, second VARS number 3, and plug in the information, your final results would be 2.3263. 3263. So we have this Z critical. Now we are going to plug in here to find that N. Okay, let's plug in. So this implies N is equal to Z sub C is 2.3263 multiplied to sigma is 2.9 divided by margin of error is 2. And then we need to square the result. So if we do that, we get N equal to 11.3780. By simplifying this expression using calculator, we get 11.3780. That means the professor has to ask 11.3 student, that is more than 11. So we can say he has to ask 12 student. So that is the required sample size. N equal to 12 is the required sample size. So that's my answer. This is the required sample size. Example, the student government organization SGA at a local university is concerned that too many students are not informed politically. At 99% confidence level, a study will be conducted to determine the true proportion of students who are not informed politically. The margin of error is to be within 3% point from the population proportion. How large should the sample size or the sample be if no previous estimation of the proportion is available? Okay, so in this problem, we want to check whether the students are informed politically, and we are doing a survey at 99% confidence level. 99% confidence level, and the margin of error is 3%. And one more information is given. We don't have any information, okay? No previous estimate of the population proportion is available. We don't have any information about the population proportion. So we are making the assumption here. So let's write down what is given. They have given C equal to 99% and Margin of error is 3%, meaning of that is 0.03. This is given, but no previous proportion is available to you. Let me write that. No previous proportion is available. If we have no idea about the previous proportion of the population, about whether they are politically informed or not, what we consider is, we consider 50-50%. Meaning of that is, this is what we consider. P hat is equal to 0.5. We assume that 50% of the students are politically informed, and the remaining 50% of the students are not politically informed. So whenever, this is very important for you to note, whenever P hat and Q hat are not given to you, you make an assumption of 50-50%. So here we make the assumption that 50% students are not informed about are not informed politically, and 50% are informed politically. So once we have this, to find the sample size for the proportion, I think you remember the formula. This is the formula. N is equal to P hat Q hat multiplied to ZC over margin of error squared. This is the formula. N equal to P hat Q hat. We have those two values. We have the margin of error 0.03. We don't have Z sub C. We have to find the Z critical at 99% confidence level. So first we are going to find Z sub C using the standard normal distribution. So along the x-axis, you have the Z score. In the middle, you have 99% area. So let's label that 99% area. This is 0.99, or 99% area is in the middle. Then once we have this area in the middle, we know that this is Z sub C and this is negative Z sub C. And area on the tail is 1% area divided into two parts, which is 0.5% on each tail. So this is 0.5% area, meaning of that is 0.005. And this is also 0.5% or 0.005. Now let's find this Z sub C. We know that Z sub C is inverse normal. Inverse normal. Area to the left of this Z sub C is 99% plus 0.5% is 99.5%, or 0.995. Mean is 0, standard deviation is 1. We can type this information in TI-84 calculator by going to second vars and number 3, and you should get 2.5758. 2.5758. That is your Z sub C. So we are going to plug in this value over here. So let's see what we'll get. This implies N equal to P hat 0.5, Q hat 0.5, multiplied to Z sub C 2.5758, divided by margin of error is 3% or 0.03, and we have to square this. So if we simplify this using calculator, if we type this in our calculator and simplify, the result must be 1842.9849. You can see that the value of N is 1842.9849. So it's more than 1842, so it will be 1843. So this implies N is 1843. That is the sample size. So the student government organization must ask 1843 students. That is the minimum sample size. This is your minimum sample size. If they take anything less than this, they will not be able to get the result with 99% confidence level. So in order to get the result with 99% confidence level, their sample size should be 1843 or more.